Good morning, welcome back. In this video, I'm going to show you or teach you how to solve exponential equation by using the same base. Okay, so the first equation I have, exponential equation, is 4 to the x power equals 16. Okay, so next step is, okay, can you, since the exponential term, basically, the number with the variable x in the exponent is called the exponential term. It's already isolated. So what we need to do here, okay, is to see if you can rewrite, okay, each term as a base of 4. So I notice that 16 can be written as a base of 4 as well. So why? Because 4 squared is 16. So now both sides have the same base. Okay, so remember, equal sign means the left number is equal to the number on the right. So if both numbers are the same and the base is the same number, so what else needs to be equal to each other? So for those two to be equal, since they already have the same base, which is 4, one needs to be equal to each other, it's the exponent. So that, again, they have the same base. So what you're going to do next, you're going to look at the exponent. So the only thing they have to be equal to each other for both sides to be the same is you're going to take the exponent and set it equal to each other. So you end up with x equal to 2. And that's your final answer. Okay. So let's try another one, number 2. So you're given 5 to the x power equal to 125. Okay, so I'm going to please pause the video and see if you can do this. Okay, so and the final answer is x equal to 3y. I can rewrite 125 as a cube, which is with the base of 5, which is 5 cubed. Okay, and now I know that both sides are the same, and already they have the same base. So for what else needs to be equal to each other for both sides, both numbers to be exactly the same, is the exponent. So that's why we said the exponent equal to each other, and you solve for x, and x is already by itself, so x is 3. So if you plug the number here, if you plug 3 into x, 5 cubed is actually equal to 125. Okay, so let's move on to another example. So we have number 3. So now remember this multiplication right here. So this dot is not decimal, it's a multiplication. Okay, so please pause the video and see if you can solve this exponential equation. Okay, so let's do this. So to solve this exponential equation, so the first steps, you want to isolate the term with the variable x in the exponent. So which is 4 to the x power. So to isolate 4 to the x power, what you need to do here, we have to divide by 6 on both sides, so that the term with the variable x, so 4 to the x power is by itself. And what you do by resimplifying, we end up with 96 divided by 6 is 16. So remember, we can rewrite 16 as with a base of 4, which is going to be 4 squared. And since already they have the same, they do share the same base, which is 4. So one x needs to be equal to each other to represent the exponent. Okay, so now let's move on to the number 4. We have 5 to the power of 4 to the x power. Okay, please pause the video and solve the equation number 4. Okay, so the only thing that I've done here, I replaced 125 by is because I can rewrite it 125 base of 5, which is 5 cubed. So now what am I going to do with the 5 cubed, the exponent of 3? I'm going to take it and I'm going to distribute to every to the x and -1. Okay, so I end up with 5 to the power of 4x equal to 5 to the power of 3x minus 3. So now the exponential equation do share the same base. So what else do I need to do? I'm going to make the exponent to be equal to each other. And solve for x. So now to solve for x, I need to combine all the variable on the left side. So I'm going to subtract 2x first. So I end up with 1x equal 0, cancel out to 0, minus 3. So the final solution is x equal negative 3. So let's move on to the next one. So you're given number 5. So 3 to the x power minus 1 equal 80. So please solve equation number 5. Okay, so what happened here is, remember, so to solve exponential equation, always isolate the exponential term. And here you have to add 1 on both sides. On the right side, you get 81. So now I know I can rewrite 81 with the base of 3. Okay, so which is going to be 3 to the 4th power. Why 3 times 3 times 3 times 3 is equal to 81. And then since they do have the same base, so what else needs to be equal to each other is the exponents. So both numbers to be the same, since they already have the same base, so the exponent needs to be equal to each other. So x must be 4. Okay, so let's do the last one, number 6. Maybe not the last one. Okay, I have two more after this. Sorry. So you have 2 to the x power equal to 132. Please pause the video and solve number 6. Okay, so for number 6, what you have to do here is you're given 2 to the, okay, so basically, I know 32 can be written as a base of 2, which is 2 to the 5th power. Okay, so now I can use the knowledge of, I can rewrite this in such a way that 2 to the 5th power is in the numerator by doing what? By flipping it. And when I flip, I have to make sure that the exponent becomes, if it's positive, it becomes negative, the opposite sign. After I've done that, okay, I notice they are already the same base. Since both power are equals, they do share the same base. So what else needs you to be equal to each other is the exponent. So I write x equal negative 5. Okay, and that's it. Now let's move on to number 7. So here's number 7. Okay, please pause the video and solve number 7. Okay, let's continue. So I noticed that 36 can be written as a base of 6. We know that 36 can be written as 6 squared, is a perfect square. Okay, so we end up, then what do I do next? I take the exponent of 2 and I'm going to distribute it to the x and the positive 1. So I end up with exponent of 2x plus 2. So now they do share now the same base. So what else needs to be equal to each other? The exponent. So I'm taking the exponent and set them equal to each other. So now I have to make sure that all the variable x are combining on the left. Then I solve for x and I end up x equals 6. So let's do number 8, the last one. So please pause the video and solve it. Okay, so now here, what do you want to do here? So we have, so what I've done here, I can rewrite 49 as a base of 7, which is 7 squared. Okay, so now I can rewrite 1 over 7 squared as 1 over 7 everything squared. Now I notice that they now do share the same base. So what else needs to be equal to each other? The exponent. Okay, and that's the final. Okay, so that's the final step. So what I would like you to remember here is when solving exponential equation, okay, so if the exponential term is not already by itself, like here number 1, or number 7. Okay, if it's not already by himself, you have to make it so. Like number 3, you have to divide by 6. Okay, for number 5, you have to add 1. So for the exponential term to be by itself. So now we notice that we can write the equation with the same base. Both number can be written at the same base. That's what we have done. And what else? So if I do share the same base, all you have to do is to set the exponent to be equal to each other, for both terms to be equal to each other. Okay, and that's the end for the video. I hope this video was beneficial to you. Because next time you're going to be solving an exponential equation with different base. And in this scenario, that's when you need to use log. Okay, so thank you for listening to me, and I hope you learned. Have a wonderful day and see you into the next one. Bye-bye.